Hello guys, welcome back to a new video. In the last video we have been done with the motion and its type, and if you haven't checked out that video, do check that out. While in today's video we are looking for the torque, which is kind of a force, and without wasting time, let's get into it. So let's understand what is torque. Okay, torque is kind of a force. Like a force have got a lot of type. It can be gravitational force, it can be kinetic force, or it can be torque. So just we can simply describe the torque, what torque is. Okay, uh, what torque is actually, this is the turning effect of a force. uh, for this we need to understand, let me write the statement simply. Torque, it is the turning effect of a force. Now for understanding this you need to look over a diagram, but just look into that. This is something related to force itself, like it is a product of the force which is present. uh, a force which is produced by another force is a torque. Like original force will produce a kind of a turning effect, and that force is torque. Now let's look into a diagram. For suppose uh, we have got a point over here, right, on this point, and uh, this is like attached over this, and like this is the axle in which it rotates. Like for suppose this is the door, and the point is the axle which is fixed. This axle is fixed over here, and uh, what will happen over here is this: when you will apply a force into this direction, when you apply force in this direction, F force, so you know, the object, or this object which I have made, the object will not move into the direction which you have moved it. Instead, there would be a resolution of a vector over here taking place, and that resolution would be like, uh, here would be the fx, and here would be the fy. Now, uh, of course, that this the object would not move in the vertical direction up toward the fy. It will move on the x-axis, rotating itself, because the result of force, like it is bound to the axle, so it will be moving result of force, but this will be moving only in this direction, either in this direction or this direction in the x-axis, and it is attached to a axle. And remember, this torque will always uh, be present when there is a force applied over a object which is attached to a axle that rotates. And this part, this section which this is object is placed and attached to axle, this is called the movement arm, and that is represented by the r vector. This is movement arm. Remember, this is important point. And this is the force we looked, and a single component force is the resultant force, and we have got angle found within this. So there's a theta. As much longer theta is, as much the turning effect will be. So simply the torque is dependent on three different quantities, which are the moment arm, the force, and the angle. So this is a symbol of torque. You know, say this is, or you can say that if you're writing t, or if you're writing t which is single curve, this is also torque, but I'm just writing over here t to make you understand. T is equal to, now torque is, remember, the product of the movement arm into the force. Okay, so over here you're gonna see that this is r into f, r f RF. You know, I mentioned all the components which I said to make the formula of the torque. RF, and the force is acting along x direction, so we're gonna write sine theta. RF sine theta, because the force, resultant force vector, is along the x-axis, so we wrote the sine theta over here. So T is equal to RF sine theta. When we remove the sine theta, we will get T is equal to R into F, because this is a vector product. If you haven't messed out how this is derived, and do look out our vector series, you will get to know that why we are mentioning uh, multiply sign over here or cross sign over here. This is a cross product. So there are also dot products, R dot F. This is not R dot F, this is R into F. So there is a reason behind that. If you don't know, just look out the vectors series onto my channel, and we can make a new definition of the torque from here. That torque is the cross product of movement arm and the applied force. And if you drive the unit, so the unit would be Newton meter. And of course there is a force involved, so this is a vector quantity, while there is sine theta. So simply here is simple math. We got to know that if the angle is theta is 90 degree, so the answer would be 1, right? And if you have theta 0 degree, then the answer would be 0. Now from here we gonna drive a conclusion, that is like, if we have got theta 90 degree, so the turning effect would be max, and if you got theta 0 degree, the turning effect would be low. So this means that as much this theta value is, as much the rotational axial theta is, so as much the turning effect to the force. And this all depends primarily on the force which is applied. uh, okay uh, this is how it works. I do hope that you've got the concept, and if you did, do like the video. Meet you guys in the next video. Till that, goodbye.